So what is the remainder theorem? Remainder theorem. It says if Px is a polynomial of degree greater than and equals to, Px is a polynomial of degree greater than equals to 1 and a is a real number. What is the role of a? Here gx is another polynomial x minus a linear polynomial x minus a. Then if we divide px by this gx x minus a, if px is divided by x minus a, then remainder will always be p of a. So if we have two polynomials satisfying these conditions, that degree of px is greater than or equals to 1 and the second polynomial is linear, then we can just put this value here in the first polynomial or dividend, we will get the remainder. This is the remainder theorem. So let's check the proof for this theorem. Proof is very simple. We will just write what we are having right now. So if px is a polynomial of degree greater than or equals to 1 and we are dividing this px by gx. So on dividing px by x minus a, we can write this dividend as product of this divisor into some quotient, take it as qx, and plus some remainder, take it as r of x. So clearly in the long division method I have told you that degree of this remainder will always be less than degree of this divisor, that is x minus a. So degree of x minus a is what? 1. So less degree from 1 is what? 0. 0 degree means that rx is constant. So clearly Rx will be equals to R, that is equals to constant. So we can put the value here. We will put the value of Rx, R in this equation. So Px is equals to x minus a, Qx as it is, plus R. So this x can have any value from the real numbers. We will take a particular case when x is equals to a is from real numbers. So we will take x is equals to a in this above equation, q of a plus r. So a minus a will give us 0 into q plus r. So we are left with r. Ultimately we are having this result. In the end we are having p of a is equals to r. Hence proved. This was the theorem. Theorem was saying that on dividing this with this polynomial, we can directly write the remainder just by putting the value of a in x. In x we will just put the value a. So I have proved that when we will put the value a in the given polynomial, we will reach to the remainder. So hence proved. Very simple proof. I hope you get it very clearly. Hope you understood. So let's move to the question related to the remainder theorem. So if we are having two polynomials that are satisfying the conditions that dividend is degree is greater than or equals to 1 and for the divisor it is linear, we can directly write the remainder. For example, if I am having this polynomial x cube minus ax square plus 6x minus a, if this is Rp of x and q of x is x minus a, we have to find the remainder. Find the remainder. So we'll see here, first polynomial is of degree 3 which is greater than or equals to 1 fine. This is a linear polynomial, fine. So here we will equate this second gx, take it as gx is equals to 0. So we will get the value of x as a. Now this value of x, that is a, here we will put in the dividend and we will get the remainder directly. So a cube minus a into a square plus 6a minus a. A cube minus, this is 1 plus 2, bases same, powers will get added, 6a minus a. So this is 0, we can cancel this out, and 6a minus a is 5a. So p of a is equals to 5a, which is the value of remainder here. So the result from the remainder theorem has been applied here. Let's see one more example. Let me write here. If I have the polynomial p of x is equals to x cube plus 3x square plus 3x plus 1 and g of x is equals to 5 plus 2x, and we have to find the remainder here. What we will do, just degree is 3, which is greater than equals to 1, and this is a linear polynomial. We can write down, we can use the remainder theorem here. We will just equate this gx to 0 to get the value of x first. So 2x is equals to minus 5, x is equals to minus 5 by 2. Just put this value x is equals to minus 5 by 2 in this polynomial and get the result. We will get p of minus 5 by 2, whatever you will get, you will have your remainder as answer. So this was all about the long division method and remainder theorem. Next we will see the factor theorem. So factor theorem is basically coming from the remainder theorem. I have uploaded a full video on factors and multiples, HCF, LCM. If you have any doubts regarding factors or multiples, you can go through that video. So what factor theorem says? It says if px is a polynomial of degree greater than equals to 1, same it is saying, and gx is a linear polynomial. If px is a polynomial of degree greater than equals to 1, a is a real number, and gx is equals to x minus a is a linear polynomial. Number one is x minus a is a factor of p of x if p of a is equals to 0. Second is p of a is equals to 0 if x minus a is a factor of p of x. So on dividing this by this, we can write this as p of x dividend is equals to divisor into some quotient plus this constant r from the remainder theorem, which is basically what in the next line, which is basically what p of a. Here we will write by remainder theorem, this line. So first is if p of a is equals to 0, we will put p of a is equals to 0. We are left with x minus a into qx. So this p of x is, this gave us x minus a is a factor of px. Why? Because remainder is 0. This is the definition of factor, exact divisor. So second is if x minus a is a factor of px, then p of a is equals to 0. I am leaving this part for you, it's very easy. You can prove this and complete the theorem. Let's check a question related to this theorem. So the question is, find the value of k, find the value of k if x minus 1 is a factor of, if x minus 1 is a factor of this polynomial kx square minus root 2x plus 1. So this is the question. Solution. So if x minus 1 is a factor from the factor theorem, we have what we have, it's saying x minus 1. If x minus 1 is a factor of, let's say this is p of x, then factor theorem says then p of 1 will be equals to 0. Or factor theorem says p of a, so here is 1, p of 1 is equals to 0. So we will put the value x as 1 here. K 1 square minus root 2 into 1 plus 1, we will equate this to 0. K minus root 2 plus 1 is equals to 0. So k is equals to root 2 will be positive now and 1 will be negative now. So this is the value for k. This was the question. Find k if x minus 1 is a factor of this. So x minus 1 is a factor of means we have to use here the factor theorem. And what factor theorem says, if this is a factor of some polynomial, we will put the value of this a here and this will be equals to 0. That means remainder is 0 because this is an exact factor of the given polynomial. So I hope you understand all the concepts very well. Hit like if you are liking my videos and subscribe to my channel and share it with your friends. Thank you for watching. Have a good day.